Alright guys, this is the video for 3.1 in the textbook. It's called scatter plots and correlation. So we're talking about bivariate or two variable data. Okay. So let's go over a couple vocabulary terms. Okay. The first one is a response variable. So the response variable measures an outcome of a study. The response variable is always plotted on the y-axis when we make a scatter plot. Okay, so kind of in algebra, we call the y-axis variable the dependent variable. Okay. An explanatory variable may help explain or predict changes in a response variable. The explanatory variable is always plotted on the x-axis. So when you see two variables, you have to ask yourself, which variable do you think explains the other one? So the way I remember it, the way I remember it goes on the x-axis. It starts with explanatory. So it sounds like x. So it's going to go on the x. Okay, and it's similar in algebra how we call the x variable the independent variable. Okay, so a couple of practice problems here to start. It says identify the explanatory and the response variables below. The legal limit for blood alcohol concentration for driving in all states is 0.08%. In a study, adult volunteers drank different numbers of cans of beer. 30 minutes later, a police officer measured their BAC. So let's first identify what the variables are. Okay. Two things are being measured. Okay. Here it says adult volunteers drank different numbers of cans of beer. So the number of beers drank is one variable. Okay. It says 30 minutes later, a police officer measured their BAC. So BAC level is the other variable. Okay. Now we have to identify which one of these is the explanatory variable and which one of these. Notice both of these are quantitative variables. They're both numbers. I can drink 0, 1, 2, 3, 4, 5, 100 beers, hopefully not. And then a police officer can measure my BAC. I can blow into a breathalyzer and that can be measured and it'll be a number. So they're both quantitative variables. But which one explains the other? Okay. So do the number of beers you drink explain what your blood alcohol concentration level is, or does your blood alcohol concentration level explain the number of beers you drank? Well, you can kind of you have to think on this a little bit, but I think the number of beers that I drink explains this one explains this one. All right, the more beers I drink, the higher my BAC level will be. So this one is the explanatory. This one is the explanatory variable. So if we were plotting these numbers for a whole bunch of people, we would put this one on the x-axis on a scatter plot. All right, and the BAC level, the blood alcohol concentration, would be the response variable. And if we were plotting these data on a scatter plot, we would put them on the y-axis. More about scatter plots in a little bit. All right. Number 2, it says the National Student Loan Survey provides data on the amount of debt for recent college graduates. Okay, so I'm just kind of underlining, okay, this might be a variable because an amount of debt will be a dollar amount. All right, their current income, okay, that's going to be a dollar amount, a number amount, that could be a variable. And how stressed they feel about college debt. Okay, it says a sociologist looks at the data with the goal of using the amount of debt and income to explain the stress caused by college debt. So maybe the sociologist has some sort of survey and they measure the stress. We're going to assume that measurement is a number value. Okay, so here we have 3 variables, but we could only put 2 of them on a scatter plot. Okay. So if we want to think about the explanatory variables and the response variable, well, what is being measured? Okay, what is being measured? The amount of stress is being measured. So stress would be the response variable. Now, what causes stress? Okay, or what, maybe not what causes, but what explains the amount of stress they have? Well, obviously, the amount of debt, if they have a lot of student debt, that would cause more stress. Or or that would explain more stress. Or if they have a really low income, that might also explain part of the amount of stress they have. So if we were to plot this on a scatter plot, we can look at debt versus stress or income versus stress. So there's actually two explanatory variables we could measure, and we could take either one of these and plot it against the amount of stress. All right. So next topic is scatter plots. So a scatter plot is actually a way to show the relationship between these type of variables, the explanatory and the response variables. So it says, a scatter plot shows a relationship between two quantitative variables. Both variables have to be quantitative, all right, that are measured on the same individuals. Each individual in the data appears as a point on the graph. The explanatory variable is plotted on the x-axis, and the response variable is plotted on the y-axis. Okay, so let's take a look at an example of making a scatter plot. And I'm going to show you how to do it by hand, and then I'm also going to show you how to do it on the calculator. All right, so it says make a scatter plot of the relationship between points per game and the number of wins for SEC football teams during the 2011 season. Do this by hand. Okay, so this was back in 2011 when the SEC had 12 teams. Now they have 14, but back then they had 12. Okay, so in the 2011 season, Alabama scored an average of 34.8 points per game, and they had 12 wins. Arkansas had 36.8 points per game, and they had 11 wins, so on and so forth. So let's first decide which one of these are two variables. They're both quantitative. Okay, let's decide which one of these is the explanatory and which one of these is the response. So we have points per game and wins. Which one do you think explains the other? So do you think points per game explains the number of wins, or do you think the number of wins explains how many points they score? Well, to me, I think the points per game explains how many wins. The more points a team averages, the more wins they're going to have, because they're more likely to win. All right, so I think that the points per game is the explanatory variable, and I think the number of wins is the response variable. So when I plot this, I need to plot the points per game on the x-axis, and I need to plot the number of wins on the y-axis. Okay. Now, Alabama, what we have to do on a graph, this represents 1 point. The Alabama football team is one individual. The Arkansas football team is one individual. So I'm going to treat these like an ordered pair. So if we're going to make a scatter plot by hand, I actually did this before we started the lesson, but I'm going to put points per game, since it's the explanatory variable, on the x-axis, and the number of wins on the y-axis. So let's just go through these one by one. So Alabama scored 34.8 points per game, and they had 12 wins. So go over from 12 wins, go over till we get to about 34.8 points per game. Just trying to take it up. 34, here's 34. There's 12. And so 34.8 would be about right there. So I'm going to represent that with a dot. Okay, Arkansas, they had 36.8. 36.8. Take that up to, it hits 11 wins. Okay, so that dot represents Arkansas. Auburn, 25.7. 25.7, well here's 25. Take it up till I hit 7. Okay, but it's 25.7. So that dot represents Auburn. Florida, 25.5, and, whoops, I think I messed that up. Auburn had 25.7 and 8 wins, sorry. So that should have gone here. All right, so that's 25.7 and 8 wins. Florida had 25.5 and 7 wins. So I'm just going to move this dot a little bit further over. Okay. Georgia had 32 points per game and 10 wins. So 32 and 10. Kentucky had 15.8 and 5. 15.8 and 5. There's 15 and 5. 15.8 would be about right there. LSU had 35.7 and 13. So 35.7, I'll take up 35. 35.7 and 13. So there's 35. 35.7 would be about right here. Ole Miss had 16.1, but only 2 wins. Mississippi State had 25.3 and 7. So 25.3 and 7. This is another dot, basically. So now this represents 2 dots. There's 2 dots there, really close to each other. South Carolina had 30.1 and 11. 30, 11.1 would be a little bit further, but right there. Tennessee had 20.3 and 5. 20.3 and 5. And Vanderbilt had 26.7 and 6. 26 and 6, so 26.7 and 6. So this right here is a scatter plot. That right there is a scatter plot. All right. So do you see a general trend? What do you notice? As the number of points per game increases, as teams score more points, what generally happens to the number of wins they have? If I were to put a line in between all these points, somewhere in between, it looks like the line's going up. There's a positive correlation, okay? There's a positive association between the number of points a team scores and how many wins they have. So that's the scatter plot. I gave it a title, Scatter Plot of Points Per Game versus Wins for the 12 SEC teams in 2011. And each of these dots represents a single individual because we measure 2 variables for each individual. So that dot is the 16.1 for 2 wins. Okay, so this dot is Ole Miss. Now, how do you do this on the calculator? Well, it's fairly straightforward. All right. So you're going to have to put your data into 2 lists. So I'm going to go stat edit. I've actually already done this. Okay. So what I did is I put every team's points per game in list 1. Okay. Remember, this is the one I'm going to put on the x-axis. And then right next to it, in the same row, I put how many wins they had. So Alabama is this first data point. They had 34.8 points per game and 12 wins. So they're right next to each other. And I did that for all 12 SEC teams. Now, if we want to get a scatter plot, here's how we do it. So L1 should go on the x-axis, L2 should go on the y-axis. So I'm going to make a little note when I do this in the calculator. I want list 1 to be for my x and list 2 to be for my y. So I'm just making a little note to myself. All right, coming back to the calculator here. Sorry about the glare there. So we want to plot this. We want to plot this data. Here's how we do it. Quit out of there. Go under stat plot. Okay, go to your first stat plot. Turn it on if it's not already. And the scatter plot, the scatter plot is the first option. Okay, it's exactly the first option. All right, well, where is your X data? What's in list 1? So second L1. Where's your Y data? It's in list 2. You can choose what type of mark you have. You can put like an open circle, you can put a plus, you can put a big dot, you can put a small dot. I'm just going to choose the big dot. And you can change the color if you'd like. And so I can change this to red, for instance. All right. So after you do that, okay, just go zoom stat. And there's our scatter plot. Now, what do you notice about the scatter plot? Okay, what the calculator does is it takes away dead space. It tries to scale it so we can see all the dots, but it tries to eliminate as much dead space as you can. So this graph looks a little bit different than the scatter plot we did by hand. What the calculator is basically doing, it's trying to kind of, if you want to look, what was our window? Our X value started at 0 and ended at 40. And our Y values went from 0 to 13. But what happens when we look at the window here? If I look at the window here, they chose to start the graph at an X value of 13.7 instead. Okay. So what it's basically doing, the calculator is saying, oh, okay, there's some dead space, so I'm going to start it at 13.7, which is about right there. All right. And it only took it up to 38.9, but that's still pretty close to 40. Okay. And then on the Y values, they started at 0.13, okay, really close to 0, and they went up to almost 15. All right, so they took out just a little bit of it. Okay, 0.13, that might be like around right there. Okay. So what they chose to do is they chose to eliminate kind of this portion of the graph. All right, they chose to, okay, if I were to take that line all the way up, if I were to take this line down, okay, they just focused where the dots are. They focused on that part. You can always go back and fix your window to match the graph we had. Like if I made it the same scale, I could say, okay, 0 to 40, that's what I put on my graph by hand. And I made every tick mark 1. Okay. And then on my Y, I can go 0 up to 13. Okay. I might want to scale it up to 14 actually, just to see that last point. Okay. Then if I hit graph here, now the graph on the calculator looks more similar to the graph we have on the paper because I didn't get rid of that space. Personally, I think when you do it by hand, I think it's important to leave I like to start at 0. Okay, I like to start at 0 along the X and along the Y. I don't like to skip. Okay, but if you do a zoom 9 again, if I hit zoom 9, zoom stat, it's going to take away the dead space. Okay, so that's how you do a scatter plot by hand and on the calculator. Moving along. So after you make a scatter plot, we need to describe the scatter plot. Okay, and we have to really describe 3 aspects of it. All right, we have to comment on the direction, the form, and the strength. Okay, so what about direction? As the explanatory variables increase, what is the general trend of the response variable? Okay, does it increase or does it decrease? All right. So, for this example that we have, let's comment on the direction. Okay, So we're going to comment on the direction. We already kind of talked about that. What happens as points per game goes up? Okay, what's the trend here? As teams score more points, what's generally happening to their wins? Are their number of wins going up or down? Okay. To me, it looks like the more points they score, the more wins they have. That's what these points reveal. So I would say the direction, I would say that there's a positive association. If it was going down, if one variable tended to go up and the other one tended to go down, that would be a negative association. Okay. Then we have to comment on the form. Okay. So we basically can do this two ways. Does the data appear to fall in a linear or a line pattern or some sort of nonlinear pattern like a curve? Are there certain clusters of data? Is there a point or multiple points that fall outside the general pattern, which can be called outliers or influential points? So looking at the data here, not all of these points, they don't fall in a perfect line, but they do fall somewhat close to a linear pattern. Okay, it doesn't look like all these points are in a curve pattern. Like I could draw in a line. If I try to draw a line in between most of those points, maybe the line would look something like that. Okay, all of those points are fairly close to that line. If I drew in a line, all the points are still fairly close to it. So when I talk about the form here, I can say that it is in a general linear pattern. Okay. Okay. And strength, we'll get how closely do the points fall to that imaginary line. Some are really close, some are a little bit further, but I would still say they're still pretty close. So I would say for strength, okay, I would say maybe something like fairly strong. Okay, and then when we put these things together, you can make a sentence like this. There is a positive, linear, and fairly strong association between what are the variables, points per game, and number of wins for SEC football teams in the year 2011. So that's what they're looking for. If they ask you to talk about to describe the scatter plot, looking for direction, form, and strength. Those are the three things they're looking for. Now, there's actually a numerical way that we can measure the strength. Okay, and what that's called, it's called correlation. Okay. So it says the correlation R measures the direction and the strength. So it actually does two things. When we talk about correlation, it measures strength and it also gives us a direction. Okay. It says correlation is a unitless measure, so it doesn't have a unit at the end. There's no units like feet or anything like that. And a correlation value is always between -1 and 1. Okay? Data that falls directly and perfectly on a straight line will have an R value of exactly 1 for positive associations or -1 for negative associations. So just imagine if all of these red points fell along, if they were directly on the blue line, then the correlation value would be exactly 1 because those dots would fall perfectly in a straight line. So if you have data that falls directly in a straight line like this, directly falls on a line, a straight line, that would have an R value of 1. If you had data that fell perfectly in a straight line, but it appears that it's going down, that would have an R value of -1. So we'll teach you how, well, it says the closer that R is to 1, so if it's like 0.99 or 0.95, it's pretty close to 1. or -1, things like -0.99 or -0.9, or, the closer it is to that, the stronger the association is between those two variables, or whatever two variables you're measuring. So some general guidelines, okay, on you're going to talk about strength, okay. If the R value is 0.8 or higher, or -0.8 or lower, in other words, if the absolute value of R is somewhere between 0.8 and 0.1, or 0.8 and 1, excuse me, then we say that's strong, okay. And maybe the closer it gets to 0.8, I might say fairly strong. Okay, if the R value is between 0.5 and 0.8, we say it's moderate. And if it's less than 0.5, we say it's weak. All right. So again, we kind of did this up here, but what you say or write on your test when you're asked to describe a scatter plot, you either say a strong, moderate, or weak. Okay, so I said that up there, fairly strong. Positive or negative, I said that it's positive. And then if it's linear. Okay, and we'll talk more about how you can really tell if something's linear later, between the explanatory variable, that's points per game, and the response variable, the number of wins. And I just went a little bit more into detail and context. So that is basically what you do. Now, you're still probably wondering about this R thing. Well, if it's some sort of number, how do we calculate it? So we're going to do one example where we calculate it by hand. And it's really, really painful to calculate by hand. We're going to use our calculator to do that most of the time. Okay. So how do you calculate this value called R, the correlation coefficient? Well, here you go. Here's the formula. That is the nasty formula how to calculate R. Very painful, especially when you have big data sets. All right, so it says take 1 over the sample size. So in our example, we had 12 teams, so n would equal 12 in that case. All right, then you want to take the sum of multiplying the individual x values minus the x average, okay, times or over the standard deviation of x, then the individual y values minus the average of the y values over the standard deviation of y. Okay. So it says, using the data from the previous examples regarding SEC football, calculate the correlation coefficient R between points per game and number of wins by hand. Then I'm going to show you the easy way to do it with the calculator. So what are all these things? Well, this is the X bar average. So what is X bar? X bar is the X average. So it's the points per game average. So how did I know that was 27.07? And what does this thing represent? That's the standard deviation of X. Okay. So SX would be the points per game standard deviation. How do I know that? Well, remember where my data was. My data for points per game was in list 1. All right, so if I added up all of these points per game for all 12 teams and then divided them by 12, I would get 27.07. So if I ran one variable stats, if I went stat, calculate one variable stats for list 1, there's my average, 27.07. All right, and this standard deviation here, the 7.16, I'm getting that right there, 7.16. And if I did the same thing with the number of wins, the average wins for all 12 SEC teams was 8.08. And the standard deviation for that list was 3.34. Okay, so Y bar means Y average, or it's the wins average. And SY is the wins standard deviation. We're only going to do this once. We're only going to do it by hand once because it's very, very painful. Okay, so let's take the first data point, Alabama. All right. How do you calculate this part of the formula? Xi minus X bar over S of X. Well, Alabama had 34.8 points per game. So we're going to do 34.8 minus, what's the average points per game? It's 27.07. Okay, over the standard deviation, which is 7.16. Okay. So 34.8 minus 27.07 over 7.16. And these will be the same in each one of these. All right. So let's go ahead and do that. So set up a fraction on your calculator. We're going to do 34.8 minus 27.07 all divided by 7.16. So we do that and we get 1 point, I'm going to round it to two places, 1.08. And then for the next one, the only thing that would change is instead of putting the 34.8 in there, I would just put 36.8 in its place. So I'm just going to re-enter what I put, and I'm going to change the 34.8 to the 36.8. And that would be 1.36. And then for the next one, change the 36.8 to 25.7. Negative 0.19. Negative 0.22. Change that to 32.0. 0.69. Change that to 15.8, negative 1.57. .21. Negative 1.53. Negative 0.25. .42. Negative 0.95. Negative 0.05. So I did that for all 12 teams. Now we got to do it for the Y values. So for Alabama, Alabama had 12 wins. But what was the average number of wins? It was 8.08. It was 8.08. And I divide by the standard deviation of Y. So the standard deviation of the number of wins, 3.34. I gotta do 12 minus 8.08 over 3.34. So 12 minus 8.08 all over 3.34. So that's 1.17. Then I have to go through and I have to do it for each team. So the only thing that's going to change in the formula, I'm going to change this 12 to an 11 there. Okay, so for this one, this would be 11 minus 8.08 over 3.34. 0.87. This one's a little bit nicer because I see 11 there. I also see 11 down here. So that would be exactly the same formula. So this would also be 0.87. Okay, so that's kind of the nice one on this. All right, if I do 8, I plug in 8. That's negative 0.02. Change that to 7. Negative 0.32. Okay, and there's a few 7s on here. So here's another 7 down here. So that's negative 0.32 as well. Right, for 10. It's 0.57. For 5. Negative 0.92. And here's another 5 down here. That's also negative 0.92. All right. Plug in the 13. 1.47. Poor Ole Miss only had 2 wins, so we'll put 2 in here. Negative 1.82. Right. And Vanderbilt had 6 wins. I'll plug in 6 here. Negative 0.62. So after you do all that, remember we're only going to do one of these by hand. I know it's painful. So the formula says I got to take this data, so these numbers, and I have to multiply them times these numbers. But you got to do it independently for each team. So for Alabama, what I would have to do is I would have to take 1.08 times 1.17. Okay, that's 1.26. So I'm going to do that for all 12 teams. I'm going to do 1.36 times 0.87. Remember, I'm going to have some rounding error because I'm cutting these numbers off. Okay, so that's going to be 1.18 roughly, then negative 0.19 times negative 0.02. And that is 0.0038. So if I round it, that's basically 0. Okay. Round it to two places. Okay. And let me just go through those. Negative 0.22 times negative 0.32. Okay, that's about 0.07. 0.69 times 0.57. That's 0.39. Negative 1.57 times negative 0.92. It's 1.44. 1.21 times 1.47. It's 1.78. Negative 1.53 times negative 1.82. It's 2.78. Negative 0.25 times negative 0.32. It's 0.08. 0.42 times 0.87. It's roughly about 0.37. Negative 0.95 times negative 0.92. It's 0.87. Negative 0.05 times negative 0.62 is 0.03. Okay, so we've done that. We've done that for each data point. Now this symbol is the capital Greek letter sigma. That means add them all up. So I got to add up all of these numbers. I got to add down this column. Okay, so 1.26 plus 1.18 plus 0 plus 0.07 plus 0.39 plus 1.44 plus 1.78 plus 2.78 plus 0.08 plus 0.37 plus 0.87 plus 0.03. Do all of that, and the sum of that is 10.25. Now, how do you actually find R? Okay, how do you find R? Go back to the formula. It says 1 over n minus 1. So 1 over, how many teams did we have? We had 12. So 1 over 12 minus 1 times, what was this whole thing? What was the sum that we just found out? Well, that was 10.25. Okay. So if you simplify this a little bit, you get 1 over 12 minus 1 is 11. So 1/11th times 10.25, which is really like 1 times 10.25 is 10.25. And this is an understood 1 under there, and that's really over 11. So all we got to do is take 10.25 and divide it by 11. And we get 0.93. About 0.93 roughly. Okay, which according to our guidelines, this is strong. There's a strong relationship. Now ask yourself, is this number, is it positive or is it negative? Well, that's a positive number. So there's a positive association. Okay, there's a positive association. So this is how you would have to do it by hand. This is how we had to do it in the old days. Okay. But the calculator is very, very smart. Okay, calculator is very, very smart. So before we can figure this out, all right, make sure, just clear that off. Go under your mode, and at the bottom you should see something that says Stat Diagnostics and Stat Wizards. Okay, make sure both of those are on. Okay, make sure both are on. Okay, so here is actually how you figure out the R value with your calculator. All right, so let me quit out of there. Make sure those are on. So go Stat, go over to Calculate, and go down to option 8, always option 8. It's called LinReg, which stands for linear regression, which we'll actually talk about more in the next lesson. But go to that, linear regression, always number 8, and hit enter. Your X list is in L1, your Y list is in L2. Okay, don't worry about frequency list, don't worry about this thing, just go to calculate. They're going to put a whole bunch of data for us. Now we'll talk about what A, B, and R squared are later in this chapter, but just look at R. What do you see about R there? It says 0.93. Well, if they rounded this, it would be 0.94. Remember I said we were going to get some rounding error here. But the calculator does all of that at once for us. Okay? It does all of that at once for us. Okay? That's the important point. All right, now let me just do one more thing here. When we had the, let's look back at the scatter plot. If I actually plotted the X bar and the Y bar average, okay, let me go ahead and draw in a vertical line. So what do I mean by that? Let me kind of show you. What did it say our X bar average was? It said our X bar average was 27.07. So that's average points per game. If I drew a line up here at 27.07, that might be about right here, 27.07. All right, and what was the average number of wins? The average number of wins was 8.08. So if I draw in 8.08, that might be about right there. I know I'm not great at drawing straight lines. How do you know if you know that imaginary line I drew in there? Where these two, well, first off, this vertical line is kind of the balancing point to keep things left and right of that. It's the balancing point along the X. And this horizontal line I drew, it's kind of the balancing point that I drew on the Y. Now notice, all of these points are up here in the first quadrant. What do you know about things if you multiply X values and Y values? What happens if they're both positive? Well, positive times a positive is a positive. What about if you're in the third quadrant here in a coordinate plane? A negative times a negative would also be positive. Guess what? That's why all of these numbers are positive. Okay, so think about what this think about Alabama here. It had 1.08 here, had 1.08 here. Let me just point out to you what the Alabama point is. Here's the Alabama point. What does that mean? This Alabama point is actually 1.08 standard deviations above the mean. Okay, this point is 1.08 standard deviations above the mean. All right, it's also 1.17 standard deviations above the mean on the number of winds they have. Okay, so if you want to think about this point, it's kind of like a z-score. Okay, this is kind of like the z-score along the x-axis. All right, this is Alabama. So they're 1.08 standard deviations above the points per game average. And this is like the ZY, they're 1.17 standard deviations above the Y average. So that's what these columns really represent. That's what these columns represent. How many standard deviations are they above or below for the X value? How many standard deviations are they above or below for the Y value? Now let's go back to this imaginary line that I drew in real quick. If it's a good line where these two things cross, okay, where these average lines cross, it should be pretty close. I mean, if I drew my line perfectly, if I drew in the perfect imaginary line, okay, it really should go through there. It should go through that center where the X bar and the Y bar come together. All right, this is my X bar line right here in black going up, and this is the Y bar line. And a good, what we call a regression line, or a line of best fit, should go through the X bar and Y bar, wherever that intersects at. So on the graph, this X bar, Y bar point would be an average of 27.07 points per game and 8.08 wins. All right, and this line should go through it, this imaginary line. As we can see though, it's a lot easier to do this on the calculator. So again, how you do that, you go stat, go over to calculate, go down to number 8, linear regression, put your X list and Y list in there, and then go down to calculate, and there's your R value, 0.936. So we were a little bit off when we did it by hand because of rounding. It's more like 0.936, but we were really close. All right, so to end this section, it says on the AP test, you're not going to be asked to calculate R by hand. Okay, it's too hard. It takes way too long. This exercise is designed to give you an appreciation for how powerful and capable your calculator is if you know how to use it correctly and how to interpret the formula. All right, so some important facts. Correlation does not imply causation. Points per game, the number of teams with point scores, does not cause how many wins that team has. It's a factor, okay? So you can't use the word cause. The two variables can show a relationship, but one variable does not cause the other. Very important point. All right, so second point, if you change your units, your R value will not change. All right, so like if you have something, you know, the height of someone in feet and how many, you know, if you measure some other variable here and you have a certain graph, all right, a certain scatter plot, you get a certain value. Let's say you get an R of 0.8. If you switch this, all right, if you change everybody's height into inches instead of feet, all right, and if this was the same thing, all right, what's actually, it might change the appearance of the graph, but the R value is still going to stay the same. It will not change the R value. And R is unitless. There's no units on the end. It's not like this. There's no units. There's never units for R. All right, we can only do correlation if both variables are numerical or quantitative. That has to be a numerical or quantitative value, so does this. If one of these is not a quantitative variable, then we cannot make a scatter plot and we cannot calculate R. All right. If you have a curved relationship, if the data is not linear, okay, if your scatter plot looks curved like that, you can't use R. I mean, the calculator will calculate R, but you shouldn't use it. All right, you shouldn't use it if you have a curved relationship. All right, and the last point, correlation is strongly affected by a few outlying observations. So if we have a good-looking scatter plot, but then there's one person that's way off, okay? Let's say, for instance, we had one team in the SEC that scored 50 points per game, but they were really bad at defense. So they only had, so if that was like 50 points per game, but maybe they only had 3 wins, okay? This one person or one team or one individual, it can really, if we didn't consider that, maybe our R would be 0.9, but by this person, it really can affect it. Okay, so the R could drop substantially. It could go down to like 0.6. Okay. So if you have a couple points that don't follow the general trend, R is going to be influenced. It will be affected. And that's where we're going to leave it. So hopefully today you learned about scatter plots, and you learned about how to calculate correlation. Hopefully you never have to do that by hand because it's very, very painful. Kind of understand what correlation is. When you describe a scatter plot, you always talk about direction being a positive or negative association. You talk about linear or nonlinear. Okay, does it fall in a linear pattern approximately? And you talk about how strong it is, and that's where the correlation comes into play. General guidelines, anything above 0.8 is considered strong, 0.5 to 0.8 is moderate, and anything less than 0.5 is weak. So, that's it.